The video is about an urban growth model built in R. The goal of this project is to use machine learning to predict urban development across space and time, a task for all planners. Our study area is the Delaware Valley region, including 10 counties centered around Philadelphia. Each of the tracts has its own geocode, which could be used to produce maps in R Studio. The main body of this project is to build a model that simulates urban land cover in 2010, using the data from 1990 and 2000, and then the same model is applied to predict land cover in 2020. The region experienced development boom in the 1990s, especially in the Bucks, Chester, and Montgomery County. There's no doubt that the region's urban area will be expanding. To find the indicators of future development, I began analyzing interesting features such as the distance to major highways and the number of universities in each census tract. Generated in ArcGIS through spatial analysis, the two variables represent access to major roads and education resources. Those are big attractors to future development. The changes of the percentage of black and white population also tell us white families favor suburbs while black communities concentrated near Philadelphia in the 1990s. There are other good predictors, like the distance to job centers, that can attract similar businesses and their employees, and total area of water in each census tract sets the limitation of future development, and also the percentage of children under 5 indicates how much the area is favored by young couples. Initially, the model has 9 variables, including the urban land cover in 2000, distance to highways, total households in 2000, total area of land, total area of water, percentage of children under 5, the vacancy rate, number of cars owned by a household, and a categorical variable, the county name. In order to build a generalized model, I dropped the variable county name, and I took a square of the land area, took a log of the dependent variable to improve the model performance. The modified model can explain 85% of the dispersion of land cover data of 2010. Based on the urban growth model, developments are highly associated with highways and vehicles, human inhabitants and reproduce, natural endowment limitations, and the performance of housing market. Those are the important factors we should pay attention to in the planning process. The model residual standard error is 1,300 square meters. Its mean absolute errors of the training set and testing set are around 1,000 square meters, compared to the medium-sized census tract, which is over 2 million square meters. The errors are ignorable. If we take out the Camden, Montgomery, and Chester County as testing sets, the mean absolute errors of testing sets are smaller than the training sets, which means there were major developments happened in the 3 counties between 1992 and 2000. To name one, the King of Prussia Mall in Montgomery had a significant expansion in the mid-1990s. Though the model is good, mapping out my predictions and forecasts is not very illustrative. Future development seems to be reinforced itself. The model is less predictive at places where major development is happening.